person now.
Should I faint? You want me to faint?
All right, so confirm if you can see my screen. I've started sharing.
Yes.
I'm recording.
Yes, I can see it.
All right. Can you still see my screen?
Yes, I can see it.
Okay. So this is our work. We don't want to. So last week, what we did was try to see other metrics that I told you accuracy is not the true test of model performance. So don't go and build model and you are saying, especially for classification, because I've explained it too. I said for classification, we talked about accuracy. For regression, we talk about mean square error, mean absolute error, how to score, mean percentage error, which means square error, and so all those errors under regression. Those are the things we use to measure the performance. But for classification problem, we have what we also use to measure the performance. One of them is accuracy. But accuracy is not enough to say if the model is doing fine or not. I have painted scenarios to let you see that the fact that your accuracy is very high does not translate to the model behaving very well, because accuracy is like a direct guess that even you can do. So your model can guess. Your model can be so sensitive to make a guess. And that guess, when you now do the accuracy, is giving you very good guess. Very good guess does not translate to the reality in the real life. Do you understand? So therefore, we do not only use accuracy alone as a metric to measure our performance. We have other things. One of it is confusion matrix. Confusion, yes, it will confuse you, but does not mean it's confusing you in the real sense. But that's one of the metric. We have the recall, we have the precision, and we have the F1 score, and we have the AUC and ROC. All these things I've mentioned, they are the stuff we use to measure performance of a classification model. If all of them now mark green, 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 as I've always say, then you can beat your chest to say, with all of these things I've gotten, my model is as good as good. Anything it gives you, I am confidently telling you that that is going to be the result you're going to have. It's not necessary to be 100%, don't make mistake. But if everything is marking green at 70, 70, 70, you can tell anybody, this my model look, I only give you 70% correct answers. Oh. Anything apart from that, my hand is not there. Oh. But it will not give you anything below 70%. So if it makes any prediction for you, have it in your head that it is behaving 70%. Do you understand? So that is the confidence you can get when all other metrics measures that same range. You get me now? And if God helps you, we're able to play around your model very well, and it's giving you like 95%, which is what you are expected to have. You can't have 70% and nobody want to more work with a model that is 70%. No, it should increase to 90 something, 90 something. Like what scenario, let's say the data is so crazy, you get 80 or something, or at least something that we can relate with. So these are the things you can use to beat your chest. So for today, we're just going to go straight to implementing them and see how they look, as God will be helping us in a very direct manner. At this point in our last class, we have seen all the possibilities of correcting class imbalance, and each of them we extensively build the model on each of them. So that means that the whole idea, I take it as a summary again. You have your data set. You need to clean the data set, check for missing values, check for duplicated values, check for outliers, whatever you want to do. When the data is clean and you are fine with it, the next thing that you expect to do is to go and use that data to train a model. But before you go and rush and train a model, if it's a classification problem, like I said, don't just rush to create a model. Check if the target is balanced. You have seen how to check for that. So immediately you notice, just using a simple value count, data frame name, column name, dot value count will show you the proportion of what you have. So if you now look at it, this data is too far from themselves. So then you now need to quickly employ the method of correcting data balance. Anyone, don't need to use the 3. I mean, don't need to use the 4. Pick anyone. It's okay based on the requirements of how your data looks like. I've explained everything to you. So, and the one we adopted in this class that we said is okay was the smooth ENN because of our own peculiarity, because of the explanation of this class. So, what can work for you might be oversampling, it might be undersampling, it might be smooth or smoothing, but just adopt one. Nobody will penalize you, but you should be able to make justification for what you are doing. I've always told you. So when you do that and you're able to correct that imbalance in the data, then your model, your data set is ready to be used to build a model. Then you build your model. At that point, at the end of building your model, you are okay. And you can now evaluate the model. That's the next thing you are doing to see if what you have done is actually good or not. Okay, which is the same thing we have been doing. So for this class, I'm just going to go straight to where we stop. This is a very big notebook that contains so many things that we have done. So yeah, this is for last class. So I want you to follow me. Our last example we did, I should have muted this anyway, no problem. Our last example that with the model we trained on, hope you are seeing my screen.
Yes, I can see it.
Good. The model we trained on was a random forest classifier, and we used the, look at where we stopped. We used the smooth ENN. That was where we stopped, right? We used the smooth ENN on the data set to correct the data imbalance. Are you seeing what I'm saying? Are you seeing it? This is the data now.
Yes.
This is the data. So at this point, we have used smooth ENN to correct our data, to correct the imbalance in our data set. We now have a new data now, which we call DF smooth ENN. So it is this data now we now build the model on. You see now, what was the next thing? We select our features, we select our, just like the way we do it, then we train and test, split the data, normal thing. Then we build our model, our random classifier model, and you can build as many models as possible. As I've always told you, at this point, you need to at least have more than 2 models that you are trying on, which we'll get there. So build a random classifier model, and then at this point, we fit the data, blah, blah, blah. We score. Look at our accuracy in this space. Our accuracy is 99%. To you, this is good. All things being equal, right? 99. But because we cannot confidently believe only in accuracy, this is accuracy. So because it's classification, we now need to explore every other stuff that we need to check so that if it is in line with this 99, we can now see or confidently be sure of where we are. Is it clear? Is it clear?
Yes.
All right. Are we all following? Hello?
Hi.
Are we all following?
Hi.
Are we following?
Yeah,
Yeah.
yes, sir.
All right. You don't forget that this is just a function. This is,
Uh,
who is that? This is a function to do the work once and for all. This is another thing I've told you. So you should not have any problem writing a function because you're going to do more function. So this function is okay. If it is that you're doing one by one, which is what we have done above, or you embed everything in a function and just call the function, it will do your job for you. You can see that place that we spent how many lines. With this function call, I have my solution. Bam. I don't have any problem. Is that okay? So that is it.
Yes.
That's where we are going to be picking our stuff from. Smooth UNN. Let me minimize. Let me comment this out. This was an assignment I gave you. I should build another. Let's even build on this one. Okay, just on the okay. This is not necessary. All right, so let's jump right ahead. Now, this is now what we want to do today. This we call precision and F1 score, and possibly do some other thing. So let's now go to other metrics. So today's class, 1, 2, 3, 4, 5, 6. So today being the 9th day in August 2024. And then what we're going to be doing today are these. Let me see about this. Hope you are still following me.
Yes, we are.
All right, good. So, what did you say? Somebody said something. Okay. So, let's go ahead and begin the job. So, do not forget, I'm going to continue from where we stopped. Please don't forget that. So, our last model we built, don't forget, was this smooth end, a random forest, whatever. Is it clear? Is it clear?
Yes, it's clear.
Okay. So let me call all those things back. My model I'm using random forest with a seed of 20. Oh, it has speak. Okay, speaking this now. This is under. I want to use the. Let me. This one I'm going to do. I will run it again. Let me just silence all this guy. I want to use the seed of 42. Let me silence all this column, and I want the cell back so that I will only be working with the last one. Ezeaku, you are finally. Thank God. I'm calling you to know if you are still with us or you are finally on Enugu Aba Road.
No, that one cannot happen today.
Okay, so I'm rerunning it again so that what we are going to be seeing is only the last model of our. So this one is just the assignment I give you that we did. You remember now? Can you see my cursor?
Yes. Yes.
I want us to be on the same page so that it will follow the. Let's just run and give us the score.
Mark, they are watching this.
It's Mark, God bless you.
It's not me. Oh, gosh, I didn't even know I was not muted. It's my neighbor.
You are your neighbor. Okay, so now this is the last model now that we'll have. So inside this last model, let's pick we splitted the data. Don't let us forget, this is where we splitted the data to have X train, Y train. This is the splitted data. X splits. So we need all of these. Oh, and do that. Just bring it so that you can see all of the stuff we have. Nothing much, it's just normal. So that everything will be on the same page. Like we don't going to be scrolling up and down. Yeah, so these are the splitted data. Hope you understand. X train, X test, Y train, Y were the splitted data when we use train test split. Are we still together? Are we
Yes.
still all right, so let's now bring all the metrics we need. Don't forget what we are doing is metrics, other metrics. This is where we are. Let me put it as also a subtopic. Other metrics that we can use for us to, that's where we have other metrics for measuring performance. Okay, so all the metrics now. So you need to import the metrics because I told you that you don't really need to disturb yourself. They are already existing in your library. What you need to do is just bring it on board. So F, whatever. So we just explain all those things for you to understand, but they are already existing, even with or without it. Are we together? Are we together?
Yes.
So let's compute the first one. We're going to compute the confusion matrix first. That's the first thing. So let me add it to this. To compute the confusion matrix, you're going to see, okay, let it be the first one that will come after accuracy confusion matrix. And we're going to see the interpretation as I've explained last week. Okay, so in computing the confusion matrix, now let's bring all the library that we need, as I've told you. So we're going to start with the first one. Don't forget we have confusion. That's the first we're starting with. Confusion matrix as the starting point. So what library do we need? How do we import it? The same way this is obtained from sklearn. Don't forget, so if you want to import the library for confusion matrix, you just do your normal from sklearn library. You remember sklearn dot. Now all these things we mentioned, I call it metrics. So it's metrics. That's the way, like metric. So it's going to be dot metrics. You get, because they are measurements. So they are like measurement that you need. So anything you are doing under this module is always obtained from sklearn. Inside the sklearn, you go to the metrics library and you can import all of everything. Is that okay? Is it okay?
Yes.
All right.
Yes.
Yes.
Import confusion matrix just the same way. Confusion underscore matrix. Yeah, that's all you need to do. Once you do this, the confusion matrix will come on board. And you can see now, so I've already bring it on board. And if you remember, when we even import our model, we always need to instantiate it. Hope that is not new. You instantiate, that means bring it on, let it be recognized. Is that not? Do you remember that?
Yes.
And so you need to instantiate this confusion matrix so that you can use it. So I can call a name conf a confusion matrix is equals to my confusion matrix, the way we have written it. You can copy Put them here. And if you instantiate, you must do this. Do you remember? Do you remember?
Yes.
Uh-huh. So what do I now need to
Yes.
pass? What do I need to pass inside my confusion matrix? Can you see what I'm passing? It says I'll pass y true and y predict. Can you see it?
Yes.
Okay, so let me take it back.
Sorry. How do you used to do this thing that those documentation came out?
Just
In my
do
own.
You press tab.
you press shift and tab.
Oh, okay.
It will show.
Shift and
But
tab.
you need to
Okay.
first of all run it. You know I run it. If you didn't run it, will not show. You know, first of all, bring it on board. Okay. Hello. Do you understand?
Okay.
If you,
Okay.
if you don't bring it on board, it will not show for you. You have to follow on it. So let's pass. We will pass. He said we should pass y true and y predict. Y true means the original y. Y predict is the predicted y. Yes or no? Yes or no?
Please say it again. Sorry.
What did you see? Y true and y predicted. So that means what you have, well, your y predict is always the prediction you made with the model. Is that not the case?
Yes.
And your y true in this case is your y test, because at this point you are only, look at what I've bring on board. I'm only talking about the splitted data. I have used X train and Y train to build my model. Don't forget. Then once I finish building it, I will put X test inside to make prediction. So it's now for me to use my prediction with my X test, with my Y predict, and with my Y test, and that will give me my confusion matrix. Let's go back and see it from the model. Now this is where the model comes from. Look at it from here. Okay, smooth and EN, this is where we have. Please look at it. Now this is our original data that we concatenate after we have corrected it. Hope you understand this. This where my cursor is.
Yeah.
This is what the data set after we have finished correcting the imbalance using smooth ENN. So at this point, the next thing you now do is to split your data, so get your features, get your target. You did not forget this. This is what took us to this line. Do you remember this now? That's the next line. Is that not? Is that not?
Yes.
So after this stage,
Yes.
what do you need to do? You split it so that you can have your X train, X test, Y train, Y test, and that's what we did here. So at this point, I have splitted the data so that I can use the one that I want to use for training, and I can keep the one that we use to evaluate my model. You understand? So, which is what we did here. So the next thing is I want to now train the model. I'll bring the model I want to train with. I'm using random forest. I brought it on. I instantiate it for this. So I passed the X train and Y train so that I can train the model with my data. And my data were X train and Y train, because this X train and Y train we obtained from your split. Is that not? Is that not?
Yes.
So I'm taking the data. You will not lose a connection. So we've already fitted the model. That means we have sent the model to school. The model has learned from train, X train and Y train. It has learned. So when the model has learned, the next thing we do is to predict. Like, oh yeah, you have learned something. Yeah, come and go to the lab. Go and operate somebody as a medical doctor, as a surgeon. After you have been trained in university for 10 years. So the next thing is for us to send to the lab. Oh yeah, go to the theater and start performing your magic. So here it was sent to school to learn. After it has learned, what's the next thing? You make prediction. So this prediction you made is what we call Y predict. Is that not? Because when you make the prediction, I want to save the prediction inside somewhere. Is that not?
That's true.
Yes.
So we got this step. So our Y predict here is already coming out. So, and after that we score. We score with X test and Y test just for us to see what we have. And our model was behaving 99%, no problem. So, but this is what we have done, and that's the step you will take. But now I want to now say, okay, I'm not confident with this 99. Let me check if other things are now in line. Then all of that thing will now come in place. So, and what is coming in place is now where we are, which is this place now. So our model has been predicting. We have already gotten our Y predict. If you want me to write it, I can also say, okay, I have already gotten my Y predict. These are my Y predicts, right? So because I've already predicted with it, is that not? So what I'm going to pass inside this confusion matrix is this predicted value and my y test, because my y test is now the original form of the test data. Because when I was doing this prediction,
Yes, that's true.
what I passed inside was the X test. So what I'm saying is that I have separated the data. Let me even explain that into you so that you can understand the concept. Now, you see, let's go back to this twin test so that you can understand that concept of all this y test we're talking about. Now, look at what we did here. You see all these thing I highlighted, this thing. These are the splits. It's just for you to divide the data into what you wanted. Now, out of this data that I have circled, some will be used for training, some will just be there for test. So the one that I will use for test, I will not let the model to see it, otherwise the model will have cheat. So that's why we always split it aside. It's okay, remove it from my data, keep it somewhere for me, so that I will use the remaining one on my model. So that when my model has done the magic it needs to do, I will now go and bring that one I kept somewhere that he has not seen before, and I'll put in the model, and I will now tell the model, tell me the answer, if truly you have learned something. So the answer is going to give me should be closer to what was the original value in that regard. So in this case, your X train is the data frame, the complete whatever. Your Y is your Y is like your target, which is what you are predicting. Don't forget. So anything you see Y represent the answer, which is your target. X is the features, and that was what we did here. Do you remember at this point? Yeah.
Yes.
So X is your features. That is all the features that all the columns that you have in your data. Y is just the target, which is in this case what we are predicting is the flood. So when I come here to split, I've already done X, all the features together with anything you see Y. You see this Y train is the splitted version of my flood. That is, it takes a larger portion of the entire column for flood and took like, well, let's assume it took like 90% of it. And I call that Y 90% under the column of flood as Y train. So the remaining column for Y is the Y test because they are both Y. Do you understand the idea now? Hello?
Yes.
You know why is a long column that contains flood, yes, no, yes, no, yes, no. So what I did here was to divide that Y into two. One will go for the training, and that one for the training is always the larger one, which is this. While the remaining one is the Y test, which is the remaining one when I took out what I want to use to train the test, to train the model. So this Y train, we always go into the model because the model needs to learn from the X train to be able to predict this guy and this guy, they are the training. So this one is coming from the Y, the column of interest, combined with the futures. And I put the two together and I will train it. I'll send it to the model to train. So when the model has trained, my X test as well is also the remaining part when I took my larger X train, which is also going to be a data frame. So if that is the case, if I've used X train and Y train to train my model, so if I send in this X test inside, automatically it should also produce the remaining part of my Y test as my Y test. Do you remember now? Is it okay?
Yes.
That's combination. So test for test, train for train, but it's the same data we divide. We just split it. It's just same data. So we use the larger one and we keep the remaining one so that when we want to check it, we can see. So immediately I build my model, I need to send in the X test because I know that if I send X test inside, that is the one I've kept somewhere. If I send it inside, what you should give me should be Y because after X test here, what follows should be Y test. So it's now left for me to compare if what I have as this is now original Y. This one was not sent in the model. I now need to compare the original Y that was not going to the model with the one that the model produced when I send in X test inside. Are you getting the understanding? Are you getting the understanding?
Okay. Yes.
So therefore, when we send X test to the model, this is the model. We send X test to it. Your answer should be Y test but we don't want to confuse it. We say, let's call that one y predict, so that because we expect that what the model will predict should be close or equals to what the y test is. So therefore, your y test is what we call the true. That is the original value. Your y predict is what the model generates. So there's every likelihood that they might be the same or they might be far apart. So, and I need to keep that in mind. That's why we need to give it a new name. We call it y predict or anything you want to name it. Just for you to have the decision. You can now compare if what your prediction is what your y test is. If it's the case, your model is doing well. Any variation is what we call the error, and you need to check for it. Is it clear? Is it clear?
Yes.
So therefore, our y predict has already been obtained. So if I want to do my conversion matrix at this point now, you can now move ahead. I will have my y predict, which is already obtained. I'm comparing it with y test. What I'm doing here is that, okay, the predicted value compare with the original value. You know, this is not the original value. Hope it's clear now.
Yes, very
Yes.
clear.
I run this guy now, and I do conf underscore maths. If I run this guy, yeah, look at what I got. I got a matrix. Is that not? Is that not?
Yes.
And I'm going to explain everything. So for it to look nice, this is the matrix. I'm going to explain it now. Let's now make it look nice so that you can see the picture. So for me to do, I'll just plot it. I'll just plot what's it called? I'll plot it in a very nice figure for you to see it very well. So plt dot figure fix size, fix your fix size to what you like. Fix size equals to maybe 10 and 5. Then let me use heatmap to show it. sb.heatmap. Then I'll pass my conversion matrix because that's what I want. I want to see this in a bigger graph. Conversion matrix. Then comma are not equals to true. Then format it as number decimal. Yeah, this should be fine. I can label it plt dot x label. My x label should be predicted values. My y label plt dot y label should be grand truth, or let's say actual, just to give it a name, actual value. So I can now run this code. Have you seen something like this before?
Yes.
Okay, now let's explain.
Yes.
Okay, so should you go ahead and explain it?
Yes,
Yes.
please.
Okay, so now what is missing? Something is missing. This value is not showing. What happened? There should be a value here. What could have been the problem?
No value for it.
There's value for it. Look at it now. There's value here, 1960.
1960.
Maybe it's just, we want it again. Don't worry. We want it again. And then on this again. Confusion matrix here. Annotation is true. Format is decimal. Heatmap. Yeah. X label. Y label. Yeah. Everything. And this is because of the color. To show now, so that we'll move ahead. benefit what is this saying? It's not showing. Confusion matrix Y predict. Okay. Let me see this again, but this should not be the reason. But let's see. Why does it take this one out? Oh, anyways, let's continue. Are we together?
Yes.
Yeah.
So let me explain it to you. Now, you remember what we did last week when I talked about true positive, true negative, false positive, false negative. Do you remember?
Yes.
So that thing is what we are seeing now, which we call the confusion matrix. So your confusion matrix comprises of that stuff we were explaining last week, exactly the way it is. And that's what you have here. Okay, so let's go ahead and explain it. We are going to use this number because this number, I don't know why it's not showing. It might be my notebook. It's not an issue. The code is correct for it to display. We can check it. So let's explain it. Now, if you open the note I sent to you, you see something TN F P TP FN TN FP or something, right? Now, how do you
Yes.
interpret a confusion matrix? Please note, confusion matrix is one of the great metric you use to check the performance of your algorithm. If you are making comparison, you want to make a conclusion in a model or in a work you did that is classification, you need to display your confusion matrix. People will just go to your confusion matrix and see what it looks like. Let's now go ahead and explain it. Now you see, if you look at this bottom, there is 0, there is 1. If you look at the vertical, there is 0, there is 1. Is that not? Mag, are you still in class?
Yes. Yes, I'm here.
Okay. Eziak, are you still in class? Because I want you guys to follow up this explanation.
Yes, I'm in class.
Okay, so we can move ahead. Now, the explanation is very simple. The class is 2 because it's either 0 or 1, and that's what you are seeing here. The class is either 0 or 1, both for actual Y and predicted Y. Do you understand this first line? There are two classes in our target, yes or no? Is either it is 0 or 1. Do you remember?
Yes.
Is either it is rain or it does not rain. Is that not what we have?
Yes.
So this is what you have for the prediction will only be modulating around 0 and 1. So also the actual will also be modulating around 0 and 1. So that is number 1. Now, if you look at the first box of the stuff we did last week, this first box is called the true positive. Yes or no? This first box is called the true positive.
True.
After this one is called the what? The true negative. Yes or no?
True.
Now, this one is called the false negative. Yes or no?
Yes. Yes.
And this is
The
called
0.
false positive. Yes or no?
True negative.
Can you see? You can open your notebook and see
True.
what.
Yes.
Now, those things we said last week, those explanation, we now want to see it now. The shortest way is that you see, this is a diagonal. You can see that there are two. They are like two distinct color, black and this. You can assume that these two color are the same thing. Let's assume, Abi. So they are just black, and there is this other color here. Is that not? Now you see this color on the diagonal. That is what you want to watch. The figures inside these two boxes is what you are caring for. Because if you go back to what true positive means, true positive says you make a positive prediction and it was actually true. Is that not what true positive said? You make that something there will be rain and there was rain. You remember, you said that this person is pregnant and she's
Yes.
pregnant. That is the truth. That means this is a correct prediction. That's the meaning. Do you understand what I'm saying? Correct predictions. Are you following?
Yes.
This TN, which is true negative, you said that your prediction was negative and your model is actually saying is supporting what you said. That means, oh, you said there's not going to be rain, and when they actually check it, there was no rain. It was supporting what you said. You get what I'm saying? Are you following?
Yes.
So
Yes.
this also
Yes.
is the kind of decision you want to make, because what you said is also in agreement with what your model said. It's also in agreement with what the actual reality is. So therefore, these two columns is our concern. This one is the aberration, is the abnormality that should not happen.
Sorry, Ola, I'm confused somewhere.
Okay, where?
You know, in the last class, when you do that square thing like that, the part that had one, that had true positive, had one attached to that quadrant.
Which one?
Like where any quadrant that has one is positive.
Quadrant. No, I only have TN, TP, TN, FN, FP. That's what we have inside the bracket.
No. Yes, that's what I mean. What
Uh-huh.
I'm saying is, like, for example, that quadrant at the top where we have 2056.
Yeah. That is
The
TN.
zero that is attached to
Forget the zero first.
true
Forget.
negative.
I've told you the
Okay.
zeros. No, the zeros is your label. That is your target. That is what your model is saying in the target column.
Okay.
So this 0 and 1 does not concern you. This is the
Okay.
nature. This is what you have inside your predicted target class. Your class, based on this thing we are doing, we are targeting flood. And flood column only has 0 and 1. Is that not? Look at flood now.
Yes,
Flood only
that's
has
true.
0 and 1. So
Yes, I know that.
all those targets, all those labels in your target are the one you have on this 0, 1. It can be anything. This one is 0, 1 because it's 0, 1. Some can be yes or no. Some can be anything it says. This one is the label you have in your target column. You understand? Because
Okay,
the
it's
value
clear
is
now.
either
Yes.
0 means there is rain, and there's no rain. 1 means there is rain. Do you understand? So
Yeah.
your concern is not here. I've explained this one that this is what you have in your label. Now, this one, the context of the matrix is what we are explaining now. This first circle, this first square or rectangle in this case, is Tn, because that graph I gave you last week. This is Tn. Tn is saying is the actual. Your model said it is, and it was so. Bible recorded that Jesus Christ, God said, "Let there be light," and there was light. So this is it. Do you understand?
In the graph you gave us, that place is TPO.
TP.
Is it TP?
TP, not TN.
Sorry, TP. Sorry. True positive. Yeah. So I just explained it as well. I said a typical example is in the Bible when Bible record that God said, "Let there be light," and there was light. So do you understand what I'm saying now? Your model said this thing is positive, and when we get to the reality, it was positive. Do you understand the idea now? So it was like in agreement with the actual stuff that we should have. So this is it. This one is saying, oh, your model said no, and when we get to the reality, it was also no. That means this is true. All this diagonal, they are the actual prediction, whether the one that is supporting yes or the one that is supporting no. This one is supporting yes. That your model is saying it is yes and it is yes. This one is saying your model is saying no and it is no. Are you getting my point now? Do you get it?
Okay.
Do you understand? This one is model says yes and
yes.
Because there will be there are two sides to everything now. It's either you are growing or you are not growing. Is that not the so everybody will have two sides. So the first side is I'm saying yes and it was yes. This one saying I'm saying no and it was no. Do you understand the idea? Those two they are the true predictions. They are the true prediction, whether in the positive way or in the negative way. Is it clear now? Is it clear?
Yes, it is.
So, and I told you, we don't.
Sorry, Mr. Ola.
Oh yeah, go ahead.
So the true positive is this 2056, and the true negative is this blank one.
Blank one, yes. Is this because the number is not there? Yes, this is blank one. But, and I told you that is your focus. So immediately you do your confusion matrix, what people want to see is what do you have inside these two boxes. You see this one, I said this black one is aberration, but the color also suggests that it's aberration. It shouldn't be. That's the meaning. That's like the wrong missing. Your model did not do what you asked it to do. That's why you have it as let's use that concept. That's why you have it as black. Are you getting my analogy now? So this is like the force, what you are not expecting from your model. Okay? Is it clear? Is it clear?
Yes, it is.
Please if you get this understanding, you have no problem in interpreting your confusion matrix. This one is saying what I'm expecting from my model, either the positive one or the negative one. Do you understand? So this is this line. Why this one is saying this is what I'm not expecting from my model to do, but it's doing it, no problem. Okay? Is it clear? Is it clear?
Yes.
All right, so let's now take it one by one. Now, come to the prediction. This 0 says, okay, at this point, my model predicts 0, right? Then, if you look at your vertical axis, is 0 against 1. Okay, let's use this small one that you see. Okay, look up. You know, it's the same thing. This is your TP. This is your TN. This is your FP. This is your FN. Okay, do you know now? So, hello. Are you following? So let's take it.
Yeah.
So now let's take it one after the other. So I will just use this one to explain the empty that we have. I don't know why it's empty. It shouldn't be empty. This number should have shown. So now let's take it one after the other. Now look at the interpretation. I'm saying when my model says there was no rain, that's the meaning of 0. When my model says there was no rain, what was the actual? On the actual, this was 1, right? It means at this point it should be rain. Are you getting me? Did the model see anything? He said, no, I did not see anything. It's 0, which is correct. Yes or no?
Yes.
Yes.
Okay. When my model says it was 0, and my actual also was 0, what was the instance? He said, I can see 2056 correct prediction that I saw 0 and it was 0. Do you understand? Let me take it again.
Yes.
Now,
Yes.
I want to compare actual to prediction by the label. I pick 0. Correct prediction. My model was not missing anything. There was no miss. When it was 0 on the actual column, I have 1. And my model did not see anything there. It did not see. It said when I was predicting 0, I am not mistaking 0 for 1. So therefore, it was 0. I didn't predict anything out. I didn't take 0 as 1. I'm standing on my word that I saw 0. So that's why we are seeing this as 0, because he didn't see it as 1. Now when we go up the same column, when I now get here, when my model was 0 and the target was also 0, he didn't see anything. He said I saw 2056 entries. Are you getting me? Which is the prediction he made.
Yes.
So he has made 2056 instances that are correct. That 0 is 0. Do you understand that language now?
Yes.
Good. So
yes.
Let's go ahead. So you have interpreted this column. Ezeaku, are you with me?
Yes,
Eze.
sir.
Okay, do you understand Eze?
Yes, sir.
Do you understand?
Yes, yes.
Okay. So this
Yeah.
is the interpretation. So we just need to see what our model has shown to us. Our model has shown that it's making a right prediction for 0. That's the summary. Is that not? Because when it was 0, under the 0 also, I saw number there, and this number is very high. In fact, for the one, he didn't even see anything, he saw 0. So I am confident that my model is identifying zeros correctly. Do we agree? My model is identifying 0 correctly.
Yes.
So because I can see that for 0, I can see 0 many. Is it clear now?
Yes.
Okay, let's go to the next one. Now, when it's 1, okay? So when my model was 1, and I get to the column of the actual, which also 1, how many entry does it saw? It saw that, oh, when it was 1, no, I can see 1,960 entries as 1. I did not miss anything. Do you understand? Are we getting it?
Yes.
Now, but when I got to 1 and 0, when my model is seeing 1 and the actual was 0, was there any miss? Was there any miss?
So
Was
what
there
did you
any
say
miss?
now?
When the model was 1 and the actual was 0, this is the actual, don't forget. What was the prediction?
Two entry.
What does that 2 mean?
Because that there are 2 entries now. That I saw 2 this.
What it means is that it's
It
making
means that it predicted that there are 2 items that are positive, like they were floods. No, that there was no. It predicted 2 items that is there, but it turns out that it's not there.
The simple interpretation is that he made a mistake for taking 1 as 0. That's the meaning. He made the mistake of 2 that is seen as, instead of seeing it as 1, he was comparing it as 0, and just 2, only 2 entries. Do you understand? Do you understand?
Yes.
That's a
Yeah.
mistake. This is a mistake. He made mistake of taking 1 as 0, or taking 0 as 1, anyone you want to put it, because there is just 2 entries there. That was just 2 mistakes. So for me, this model is doing very well. So this is just the only area is making little mistake, and the mistake is not much. Imagine if 2056 is what we now have here. Is that a good model? Hello?
The
Bad.
worst.
Be a bad model.
If 2056 is what you have here, is what you have inside this bracket, is that a good model?
That's the worst model ever.
Because
But
the truth is that
wait, what if the value in the true positive is like 1 million? So
it doesn't matter. I've told you.
Yeah.
True positive does not. I told you that this is your goal. This value must be higher than this one, these 2. Must be higher
What
than.
I'm saying.
Must be higher than.
If the true positive now is like 1 million,
Mm-hmm.
and this black one, I don't know how that I'm not used. This black upper one is like 2,000. Would you say the model is bad?
Yes, because you have to compare. You must compare these. Can you see where my cursor is? You must compare what you have here. Because what you are saying is, out of how many entries? Let's assume that the total entries for any column here, let's assume is 3,000. That means the addition of this and this together is 3,000. Out of 3,000, this one is already taking 2,000. This one is just 1,000. Is it behaving very well? Hello? You're not answering me.
Sorry, what did you say?
Do you understand the Mag?
Please, can you repeat it again?
Okay. She said, what if this one is 1 million, this one is 2,000, and maybe this one is, let's say, 500. And we still say that the model is not behaving well. I said, yes, it's not behaving well. How do you
It's
want
not
to
behaving well.
How do you want to know? Now, the fact that this one is higher.
Because you're wrong.
No, just wait. The fact that this one is higher and this one is even higher does not mean that the value I have here, even if it's small, I will say the model is not behaving or is behaving well. Look at the logic. Just do some whatever you have here and whatever you have here. That will be total possible entries on this axis. Yes or no? If this is 2,000 and here is 500, it means the total I can have for this one is 2,500. Is that not? Is that not?
Yes.
So out of 2,500, out of 2,500 entries, the wrong was already 2,000. So how can I have error of 2,000 in 3,000 and I'm saying the model is doing well? Are you getting the idea now? Just for you to add the entries in these 2 columns together. When you add it, now see how many proportion is this one taking. If it's more, already it's not behaving well. Do you understand? Regardless of even this one is 1 million.
Yes.
Bless, are you understanding it? Because by the time you come here as well, you compare this one with 1 million and what you have here. If what you have here is just 500. Okay, 1,500,000 is far. I can say at this point, this is not my problem, because if out of 1 million, I'm only missing 500 entries, it's not really a problem. Are you getting the idea? But when I have 2,000 here and I have 1,000 here, let's say I have 2,000 here and I have 500 here, total entry is 25. Out of 25, 2,000 is already error. So there's a problem with one, but my zero is behaving. It's not like the zero is, it's not as if it's seeing the zero perfectly, but the zero is still better seen than the one. That's the conclusion you're going to be making. Blessing, are you okay? Blessing. Should I take it again?
Yes, please.
Okay, please listen, because you need to understand this interpretation. It's not, the truth is that you cannot read it in any text for you to understand. You should have to pick explanation as to how it works. Now, let me use one so that you can see the number. This is our 4 squares that we have. Okay. Now, we said, let's assume on based on your assumption, total entries between this and this. Total entries here is 2,056, because by the time you add 2056 and 0 together, we give you 2056. Yes or no? Which is the total possible output you can have for
sorry, Ola, please. Hello.
Yeah, go ahead.
Sorry, please. Is there a way you can edit your cursor icon so that it will not be showing this tiny line, like something bigger?
No. I can't.
There's no way.
Yeah.
Oh, okay.
But the cursor is not the problem. I don't want me to put the cursor is not the problem. I think you should be able
No,
to.
I want to be able to be following where the cursor is.
No, the cursor is going back to where we are. Where are we now? Oh.
Yeah, in that confusion matrix, Ari.
I'm trying to get there. Now, this is our confusion matrix. Okay. Now, see, can you see now? Can you still see now, Mag?
Yes,
It's
yes.
big enough now. Okay. What we are saying, this is the same thing as this one, but because we did not see our figure inside here, so we want to use the one that we can see. Now, we have this one, and this one is one entry. This one and this one is another entry. For me to compare them, I will need to compare. First of all, my interest is that I can see that on the diagonal, these numbers are higher. 2056 and 1960, they are very high. So I'm confident that, okay, my model is looking very well. But let me check all other columns. Maybe there are no numbers there. And if they are, maybe they are something I can deal with. Now, if you compare with what Blessing said, 2056 and 0, it means that total entries I can have for my 0 entry is 2056. That means there are 2056 zeros in my data. Okay? So out of that 2056 entries for zeros, I saw that my model saw 2056. It was not missing anyone because it didn't miss 0 for 1. You get it? So at this point, I can say that my 0 detection is okay because every entry I have as zeros was seen by my model. Okay? For zeros. Is it clear?
Yes.
Blessing, is it clear? Blessing.
Yes, sir.
Is it clear?
Small. I'll
Please.
watch the recording and
now for this one, when you had this and you had it together, this will give you 1,962. Is that not? Okay. So 1,962 were the possible entries for my one. Yes or no?
Yes.
Okay. So if you now know that the possible entry I can have for my one is 1,962, and I can see that my model saw 1,960 as one out of 1,962. Can I conclude that my model is seeing my one very well or not?
Yes, it's seeing it very well.
Okay, because
okay.
out of 1,962, you only missed 2. So it's not something I will have to give myself headache over. But let's now reverse the case. Let's reverse the case. Okay. Let's now put 1,960 where we have 2. Okay. And put 2 where we have 1,960. Is it clear?
Yes.
Yeah.
Okay. When we still had it still give us 162 on 1962. Yes. But
Yes.
what is the how many one is saying? In this case, it's only saying 2.
You're saying 2.
Is it correct? Because that was like, how can I have one entry and only seeing 2 of 1 correctly? Then there's a problem. Is it clear now? Okay.
Yes, it's clear.
Yeah.
Exactly. Are you also clear now? At this point, exactly. Have you slept?
I said I won't sleep today.
But is it clear now?
Yes, it's very clear.
So please, this is what you need to understand. You need to cram. So at this point, I can say that confidently say, okay, for my conformal matrix, my model is seeing my 0 correctly, and it's only missing 2 out of my 1. Is it clear now?
Yes.
Do you understand?
So,
Yes, very, very.
so in other words, your true positive, like 0 is 2,056. Why 1 is 1,960, Abi?
Yes.
Okay.
So, which is what I said now. At this point, I can confidently say that anytime you ask my model to predict zeros, it's going to predict everything correctly. But if I ask it to predict 1, it will miss 2. Do you understand can you see the layman interpretation now?
Yes.
You need to drive it home. Because you have 2 things that is predicting. It's predicting 0 and it's predicting 1. Okay, I know well with this model, my model will always get all the zeros input correct. That means when it says there's no rain, there's no rain. That's the meaning. But when it says there is rain, you know, maybe in every 1,000, if you predict for 50 days for you, maybe remove 2 days out of it, there will be rain for 48 days. Do you understand? That's the meaning of this interpretation. If my model says there is no rain for 50 days, there will not be rain because 0 is correct. But if it says that there will be rain for 50 days, yes, but remove 2 days out of that 50 days. Because that's the miss. Are you getting the logic now? Which means there will be rain for 48 days. But you might not know the actual day but you know that my model is already missing 2. So these 2 days in every 50 days, there might not be rain, even if you tell you that there will be rain. Are you getting the logic now? Can you see the interpretation?
Yeah.
It's as simple as that too. Is it clear now?
Yes, very clear.
Are we confident that we are clear now? Okay. So if I give you any interpretation of any confusion matrix, that's what you need to do. And this is very, very critical. So another stuff now. So we are good here. So our model is collaborating. So when we say that's why that was why it's not 100%. That was why the accuracy was 99%. That simple 1% is what you are seeing here. Okay. If our model has shown 1%, if our model has predicted like our accuracy look like 100%, then there will not be here. This and this will be 0. Okay, because it's not missing anything. But because it was not even 100, model does not lie, equation does not lie. If you do the right thing, you will get it. Our model already is 99%, okay, which is good. So I also expect that there should be some miss, but I might not know where the miss will be until you complete your confusion matrix. When you now complete your, you now say, okay, because the error can be here, it can also be here, it can be anywhere. Do you understand? But there will be miss. And here has shown us that the miss was only on 1. It was only missing it on 1, but it was fine for 0. That scared me. Is it clear?
Yes.
Yes, it is.
All right. So, Eziaku, are we good? Because
I have a question.
Yeah, go ahead. So this is important. This is
Do
important.
we need to know the mathematics of this thing?
Did I explain any mathematics here? I've explained what you need to know, and it's okay for you. Because I told you there's no cramming anything. We import it from normal library. We do like when we are doing .fit, we pass our y predict y whatever. Our confusion matrix come out. Even if this is what you do, But just that this is not really visible. That's why we make it visible. And because of our visible, one is not showing, but there's no problem. Since you can see this, you can make your interpretation real quickly. When you now see this graph, this table, how do you interpret? I've just given you the interpretation because that's what you need to know. And by the time you're now writing, you can write extensively on this table. And somebody will know that you know what you are doing. Because not everybody understands how to interpret confusion matrix. Not everybody. They can plot it, you can look at. Yeah, come and explain. There will be a problem. Are you with me? And that's what we have done today. It's so important. Is it clear? All right.
And yes, please. All this that you explained about this whole matrix thing, I understand it too. It's just one ticking thing I want to ask. These actual values that you wrote on the labels, actual values and predicted values, no verse abeg. Can you pinpoint the one that is the actual value?
Is that what?
The two that are the actual values.
The two. Which one is actual value? I didn't get that part. Repeat your question.
You know, as you did this label, your label, your matrix label, that you did y label, actual values, then your x label, predicted values.
Yeah.
Please, can you touch the two that are actual values? The two that are actual values. I want to see them.
That actual value. I don't get actual value as how.
No, you know, in this your plot,
0 and
you said
1. She's asking that which one is the actual value.
This column,
yes.
These are just label. What do you have inside your y? Your y is always 0 and 1, but I want to make my axis to have a name so that I can compare. So I said for my x-axis, the values inside your y is always 0 and 1. But I have it at two different places. Confusion matrix will show you for x-axis and for y-axis, and I need to give it a label. I just said for x-axis, call it predicted. For y-axis, call it actual values. They will always be 0 and 1 because that's what your y has. I've shown you initially that look at your y. Your y is between 0 and 1. So the confusion matrix has a way of collapsing the entries you have into unique identity. And when you look at it here, unique identity, if you do y test dot unique, what did you see? How many entries do you have in your y test?
1 and 0.
That is, so your 1 and 0s is what you have here. 0s, 1. That is what you can have in your y. But how many times is each of them occurring is what you are seeing inside this whatever. So your actual values here or your predicted values here, they are just labeling. We are just giving the names to axis. We are just giving the names to the axis so that we can differentiate the two. If I did not put label, not that it will not still come. Look at if I close this, if I mute this, and I run this guy. You see that, but I will not be able to know, okay, which one will I call my x, which one will I call my y? Do you understand? You can see that they still return your 0, 1, your 0, 1. Is that not mag?
Yes.
But I need to make it funkify. I want to give it a name so that I can know that this one is x, my x represents my predicted, my y represents my actual. So that's what I just included this in the plot so that I can have it interpretable. Okay? Okay?
Yes.
Okay? So your actual values are 0s and 1. Your predicted value is also 0 and 1 because it's either it is rain or it is not rain, both for prediction and for the actual. And that's what you are seeing as 0s and 1 here and 0s and 1 here. Is it clear? Even if I want, I can take my x-axis to be my actual. This is not a problem. You can come here and say, okay, you know what? Put this one here. Put actual on your x. It's your choice. All this thing is just manipulation. I put this one here. And I come here, do this one inside. So that I change the way it is being interpreted. I don't have any problem. It's me that I want to have it and I run it again. It will not stop it to run. It has run. The only thing that I've said, okay, on my y-axis, my y is my predicted, my actual is my x. You see now that the label does not matter. Are we following?
Yes.
It's just for you to give it a so that somebody can clearly see the comparison, that if you actually is 0 and 1, your prediction is also 0 and 1. Okay, can I compare? Then they now do the comparison and see where the values lie. Eziaku, are you still in class?
Yes, sir.
Do you understand, Eziaku?
Yes, yes, I understand.
Okay. Magna, do you understand?
Very well.
Blessing, do you understand?
Yes, I understand.
All right, glory be to God. So let's move to the next one. Accuracy. What's the next one? So please, this is the explanation you need. The truth of the matter is that I have not seen the book that you read that will explain it. They will write it in words, so but getting the concept is not like clear like clear. You understand? You will read it, but you'll be looking at it. How do you want to even interpret this grammar? Because for everybody, it's always edic. So once you know it, you know it. And that's the explanation I give is what you need to know. For anyone that you do, even when it is multi-class. So for accuracy, no problem. We also go into our sklearn library to go and bring our metrics, as I've told you. Metrics. We want to import accuracy score. So we also import. This one has come. So let's do accuracy the same way. So accuracy score will be equals to accuracy then pass x and y. X and y test, you pass the same thing because everything you're passing is because you're just trying to test the model based on the predicted value against the actual value. I do this and I do arc score arc underscore this. Can you see the accuracy? You can see it was the same thing we got when we do the score, and that's what I told you. So even if you not do the score, this is another way to calculate accuracy. Can you see the score? You see this one?
Yes.
No, it's not this one. This is it. Okay. Do you
Yes.
see? Okay. So accuracy is the same thing as is that you come here and do import accuracy or you do your dot score, you're going to get the same thing. Blessing, any question? You see the same thing. So either you are doing dot score that we have always learned, or you import it as accuracy score. It's the same thing. So accuracy you see that is computed by doing dot score to give you, or you come and import it from SQL library. Is it clear? Is it clear?
This one is simpler. This accuracy is straight to the
So you
point.
know it's simpler because you now know there's a library. But if you know there's a library,
Yeah, it's true.
okay. Is it clear now?
Yeah.
All right, good. So should we move ahead? See that
Yes.
there's not. So the only one that you need to worry about is that confusion matrix. So we'll go to the next one. The next one is
Record.
Is it precision should come before recall?
Okay.
The next is precision metrics. So metrics precision. The same way you go to our library. By now you should know the library. Eziaku, tell us the library. It's the same thing. The name. By now you should just what's the library, Eziaku?
From sklearn dot.
sklearn dot. Oh yeah. Dot what?
Precision.
Dot
Metric.
dot metrics. Import.
Precision.
Is it only precision?
Precision. Precision
Precision
score.
score. Precision score. Because you can see accuracy score, precision score, all those will be score. So we need to instantiate it. If you instantiate it, precision equals to the same way you pass your X train and Y predict and Y test. I put it, I do my precision score, I copy this one. I'm not disturbing myself, just be copying it because this is what we are varying. We are checking the difference between the actual that was predicted versus the original. What was the precision? Precision was, can you see? 99. You can see that all of them are agreeing. Okay. Are we following? Then the recall.
Yes.
We go to the recall, right? So recall metrics. So by now I believe you tell me the library straight. Metrics recall. So, Blessing, what's the library? What is the library? Blah, 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 blah.
Sir?
What's library? Want to do recall?
From sklearn.metrics.
Metrics. Metrics.
Yes, metrics with S. Import. Would you say record score?
I've told you everything. Score.
Okay, recall score.
Underscore. Yeah. Okay.
Yeah, this other part is simple.
Is there everything is simple?
Nikki, that confusion. It's just sounding like the name.
Please. I hope you understand. I don't want you to tell me, if I ask you to tell me that you didn't even understand on the confusion matrix. It took time to explain. I'm not joking. If I ask you, I tell you
It's not at once, person. We should be small.
I didn't say now. I said later if I ask you. Don't tell me I understand. If I
but maybe we can still ask questions.
Of course now, but when I say when we not get to a point whereby we plot a confusion matter and I say Blessing, explain it, and I say me understand that you know I'm going to send what's it called? I'll send these people to you. Come and greet you. Can you see the recall?
A very good model.
Okay. What's the last one? F1 score. Okay. You see this one means 100%. Hope you know. My people.
Yes.
One is 100%.
Yes.
So that because that Mag will be saying now that one is one. That no, it's one is different from it's 100%.
I know, Joe.
The one is F1 score. F1 score, which is the ratio of the precision and the recall. Okay, and we want to see it, and then maybe we'll call it. Yeah, it's almost time. See, so tell me the library from who I've not caught. I've not caught Ezeaku. Easy, no, I've caught Ezeaku. Mag, don't come and use it for me. I've not caught.
From sklearn.metrics.
You'll be doing voiceover.
Import F1 score.
Import. Are we good?
Yeah, we're good.
Are we good?
That's import. You put it.
God will bless you. I purposely write it, and you see that it does not turn green. You should know that there's a problem. Everything one we have been written, it will turn green because it's an inbuilt.
Yes, it's even the F1 I was looking at.
Why did you do it on purpose?
Because I want you to know. I want to check if you are following now.
You can never understand the way this our coach used to whine us.
I want to know if you are following. That's why I did like that. So just copy this one now. I will pass the same arguments on it, your Y test and Y predict. So let's see what the F1 will look like. And if everything is marking green, just like the language I use, then we know that this model at this point, let them go take it to the moon. We are confident that what we say it will give you is what we're going to give you. What's our F1 score? F1 score. Okay. So you see now, do we see?
I think this score is the same thing as. Please scroll up small. Let me see that.
It's not the same thing. It's not the same thing. It can
Okay.
never be the same thing. You can only get except your model is 100%. Everything will be 100%. But if it's not 100%, there will always be some little differences. Okay.
Oh, we can push this model out. We can sell it now.
Yeah, you can for prediction. But you don't forget for it to be sellable, there are a lot of things you have to pack it very well, right? Okay. Yeah.
Okay.
Is it okay now? Is it okay now?
Yes.
Yes,
we can see that at the end of the day, what can you say about this model? We can confidently say that, number one, our model identified all the no rain correctly. and it only misses 2 when they say there won't be rain. That means, for example, if you use our model to predict for 50 days of no rain, you're going to get 50 days no rain. But if you use that same model to check for 50 days that will be rain, there will be possibility of missing 2 days that it will rain when it has said it will not, or it will not rain when it has said it will rain. Do you understand? Interpretation 1. Then we are confidently saying that our model on average is 99.9% accurate. That's your summary. Because everything is 99, 90, whatever. Do you understand what we are saying? And that's all. And this is confident. Let them take it anywhere. This model will be. And the truth is used to predict anything. That's what you're going to have. Is it okay? Is it okay?
Yes, sir.
Yes, sir.
All right. So what we are left with is AUC ROC. So I will write the code now. Then we will see the graph, how perfect it is. So let's quickly do that so that we know that we are done. This metric is what you need to know. And you need to do it every time you are doing a classification model. Once you finish your model, blah, 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 you need to run this 5, whatever, and check. If your 5 is okay, and then you're good. You can now imagine if it's also a population. You want to push to GitHub or LinkedIn. You now need to be all this grammar that we are saying. You write it in words. With the confusion matrix obtained above, it's obvious that my model will identify every instance of 0 correctly with a short of 2 when it's identifying the class of 1 or no rain. Period. Excellent. You are good. There's nobody that person does not need to understand math. Does not need to know the behavior of, you have communicated your findings. Now, okay, this is okay. If it's just 2 in every, that means in every 1,000, you just missed 2. And that's not a problem. Do you understand? This model is still good. Are you getting it? Basic. Are you getting it? And that's all.
Yeah.
Same thing for if it is Earth. Let's assume that this model is for identifying that people will have cancer. And this confusion matrix is showing that what we are telling people is that my model, if is deployed into whatever, it will identify people with no cancer accurately. Like, let's say that one is 0. And people that has cancer, let's say that one is 1, with a target of missing of 2. You understand? Maybe in every 100 samples it's doing, maybe we will match or mismatch 2 people that have cancer, and we tell them they did not have cancer. So you might need to further, carry out lab tests on those one that is having cancer, so that we can be sure that they actually have cancer. Do you understand? Communication. Are you getting me? Because in this case, if it's cancerous, whatever, I don't have a problem with 0. 0 means no cancer. So I don't even need to worry about that, because my mother has already told me that he will be able to identify people without cancer correctly. But people with cancer, he might miss 2. So it means that if we use this model on people for 10 different people, we need to also again try to do lab work for them, because there might be 2 that he has said they have cancer and they do not have cancer. So you don't go and be treating people where they do not have cancer. So they might just need to randomly do tests for few of them to be sure that they really have the cancer or they don't have the cancer. Is it clear now? Is it clear?
Yes, very clear.
In the same thing, if you're in your work or you are in your workplace, what was her name? Let me use people are Greek now. You administer a vaccination to your chicken, or a vaccination was developed, and they now do it in a way that they run the test, blah blah blah, and that vaccination, what it's going to do is to prolong the days of the chicken. And when they run the test, maybe they will die, they will not die. That's the summary of the output. So your model now says, okay, with this model, some of the sample we have taken, the model can see that when it says the chicken will not die, they will not die, which is like 0. But when it says they will die, in every prediction it made for total numbers, like in thousands, it has a chance of missing only 2 predictions that you will say they will die and they might not end up dying. Maybe not. These are interpretations to what we are doing. Is it clear? Is it clear?
Yes.
AUC curve and ROC. Okay. This is the final. It's just for you to show the graph of what this rubbish you have been saying. And you're going to see it and you see the overall performance. So we need to also import from sklearn.metrics. We want to import ROC underscore curve, because the curve is a graph. I also want to import ROC underscore AUC underscore score. This is what you need to do. You need to do the ROC curve and the score. So we need to compute. Some things. There's what we call FPR, PR, and then TPR. TPR is just grammar. So let me write it one by one. False positive rate. False positive rate is already in the definition I gave you. TPR is true positive rate. It's just the rate of making a false prediction, and this is the rate of making a true prediction. The TN and TP. That's what this guy is talking about. Okay. Actual. Is that fine?
Yes.
So it's the same TN and TP, that one that has a value. What we are saying here is that this is the graph. This is what we are talking about. Down the actual, when this is no, don't forget I told you that this one is the actual. God said, well, let there be light, there was light. That is it. Yeah. This one says, this is like, it says it's no and it's no. When God says he's going to do something, he's going to do it. When it says it's not doing it, it's not doing it. Like to everything in life, there's always positive and negative side. So if it's positive, it's positive. It's negative, it's negative. That's what it says. So that is the concept of this FPR and TPR. When it is false, I want to know the rate, the proportion of the false, those ones that are negative actual, and the proportion of those ones that are positive actual. That's what it says, so that I can know my proportion. So this is already in the note I gave you, basically. So what we need to do is, at this point, let me make this one, but this just need the code. So in this case, I need to make some probabilities calculation. What was it? The model was still model dot predict proba, then passing your y test, which is what we have as original, then the probabilities of predict this as x test. Predict proba x test. Yeah. Then my probabilities. Predict random for alternative predict proba. Oh, and we need it. Okay. And I want to plot that. Are you still there?
Yes, sir.
Hello.
Yeah.
Okay. I want to plot that. You see, we need to compute the probabilities. Okay. Yeah. Probability should come here. Yeah. This is the probability. What he's saying here is that it's just a code. What I want to do is, because I need to compute the curve, so there's a need for you to compute the probabilities of the chances of, this is not 0 and 1. No. This is the probability of how many zeros, when it was 0, what's the chances of 0 occurring in each of those lines. If the first prediction is 0, what's the probability of that 0? Maybe it's 1/5, or maybe it's 1/10, depending on how it is, but mathematically it has computed it for you. You don't have to put it in your brain or disturb yourself. But because I need it, why I want to plot the graph, that's why I'm doing this. So we move ahead. The next thing is you want to identify your FPR. your TPR, then your threshold. Threshold. This is just a code. Then I'll bring in my ROC. I want to see the curve. Once we calculate that probability, because we will need it, that's the first thing you need to do. Your ROC. Then put your y test and the probability. Y test, comma, the prob that you have done. Let's grab everything on the row, comma 1. Then this will be my probability. Then my AUC curve, AUC score will be this. I've already computed. I need AUC score. Just hold on. Will be ROC score because I need this score. I've gotten the probability. I'll also take the score. Then I pass in my y test, the same thing I passed. Like this. The props. Voila. Control C.
What are you doing?
I'm trying to just wait. I will explain to you. So my even is just need to. This is the code FPR. Your FPR is this. Yep. Your TPR. Just want to show you your threshold. Thresholds. Yeah, your AUC score. UC score. Why? Good. So your AUC score is already 1. So let's go and plot the graph. I will explain everything to you, but this code is just what you need to know. Get the probability, calculate the FPR, the proportion of each of the true and the false. Then calculate the AUC score for each of the predictions, so that you can now plot it. So if you want to plot it now, let's plot the curve. ROC curve. That's our final destination. So we are using PLT dot as our normal. It's a line graph. Put all of this FPR, the threshold, FPR, TPR, then label equals to AUC equals to okay. And that's not AUC underscore AUC score. Yep. Then you can stretch it further. Hope you are not sleeping now, so that you're not gonna leave me. Hello.
It's like
Yeah. You're wondering the magic that you are doing.
I just want to plug it. Don't worry. You can even copy this one and save it somewhere. It's not like I just want to plot the graph. You see when I'm done, you see the graph. It's nothing. Okay, I cannot be ready. Okay, false positive. What I have? False positive. Wait, what did I have? That's why
you have made mistake.
Where?
Your PLTT.
Yes, in the PLTT.
Okay. Thank you. You are following, you know. First time. I thought you have even gone to bed. This today is good though. Blessing. Hey. I thought you have gone to bed. Two positive rates, which are the two. PLT dot to the title of the curve is arrows AUC arrows AUC curve and the agent. Eziaku. Easy. Okay. Are you sleeping? Have you
No.
slept?
How?
Your voice is a bit down, so we just want to be sure.
Because she's awake today now, we will not hear word. How? So she's asking how.
All right, good. Now let me explain.
It's triangle.
It's not triangle. It's telling you, look at the AUC score. AUC score is 1. So this graph, this is behaving very well. Let me explain to you what you need to do. You might copy this code because it's just once you need it anyway. I might copy this code somewhere. Okay. Now this is what you need to do basically. Whenever I want to do the graph, for the graph, which shows the progression, a straight line means the model is well posed, like there's no problem between the actual and the predicted. So what you need to do is ROC curve and ROAUC curve. All of this is, I've explained it in the notes, ROC and what is AUC. These two you need for you to confidently interpret all this rubbish you have done. This is the interpretation in terms of the graph. If you don't get to the graph, there's no problem. At least all the stuff we have done before this graph has shown to you that the model performance is very, very good. Okay, but for advanced whatever, okay, can you show us the AUC curve? Okay, fine. AUC curve is okay. I compute after importing the ROC underscore curve and ROC AUC score. So I will need to get the model to give me the probability of each of the prediction, because don't forget that when we did model.predict, we passed X test there, and that gives us the prediction. What this one is just telling you is to see, okay, if the model predicts 1, what is that probability of that 1? What is the chances in the entire, if there are 20,000, if there are 10,000 entries, and your model predicts 0, it's going to look for the probability of that 1, that 0 is predicted in the 1,000 or in the 10,000. Normally, it should be like, let's assume it's only occur 1. That would be like 1 over 1,000. For example, if the entries are 1,000 entries, if my model say 0, what is the probability of that 0? It's going to be how many times do we have that zeros in the entire 1,000? That's the probability. That's what this one does. And why do I need it is because we're going to plot the graph. And because don't forget, we said FPR, TPR, positive rate. I want to know how many chances is my positive occurring in my entire data. And how many times will I also get the negative? So it's probability. So therefore, that's the essence of we computing this. And immediately you have this, you impose your ROC, just like when we do recurse score, then you pass your Y test. But in this case, instead of passing Y predict, the Y predict will now be the probability of, because it makes use of probability because of the positive rate. The rate is proportion. So instead of normally, when we did the recall, look at when we did the recall, for example, we just pass this directly and the Y test and the Y predict. The same thing we are doing here. Y test, this is your Y predict, but in this case, the probability of everything in the row with the first column in this case. So it's just the same thing as your Y predict, but I'm only taking the probabilities, not the actual prediction. In the one we did, we're taking the actual prediction. Can you see? We're taking the actual prediction, okay? But in this case, in the case of AUC, you take the probability, and that's the essence of you, first of all, computing the probability of each of the predictions, and you send it into the whatever, and extract what you need to extract to represent your Y prediction, but in terms of their probabilities. And once you do that, you have your FPR, TPR, and your threshold, because you need them. So immediately you do this, then your AUC score also take the same format ROC score, I want to calculate my area under the curve in my, so that when I plot it, I want to see the area that model covers out of 100%. How many, what is the coverage area? You know, when we do your elementary mathematics, and you still pass the same input as to your ROC into your ROC AUC score. And once you get these two, then you can now put this one somewhere and input the value. Plot FPR and TPR together. This is just the label. This is just formatting. Then plot the second one under the interval of 0 and 1. Use this as my decorator, how the line should look. I'm saying use a dash line. If I say use a plus line, you will see it. Then give X label, give Y label, give the title, let the legend be under the lower right. Legend is this label, AUC curve, and that's all. So what we are saying is that the interpretation of the graph between 0 and 1, this one is your positive, this curve you see, this one, this line, this blue line, that is your actual, like the real one. You see this one you saw, that is the prediction. You see that it's a straight line between all of the whatever you have, and this curve, this graph covers exactly half of this page. Look at this square bracket, this square that you have. The entire line looks like it divides this curve, this square, into 2 equal halves. You understand? Because this line, look at it here, from this point to this point, it divides the entire square into equal halves. There were no biases in the prediction. Everything is telling us is accurate, and that is the major thing. But that's not the goal. The goal is, what is your AUC? So your area under the curve is 100%. It covers all the areas that the prediction lies, and the prediction lies between 0 and 1, because the values that you have in probability should be between 0 and 1 inclusive. So it covers for everything. Look at it from 0 to 1, and from 0 to 1, everything is covered. So it's 100%. So the prediction, the probability is fine. So for every predictions he made, the probability can be found. You can see it, and it's as close to 1 or as close to 0, depending on the cases at which you have it, and that is all. So if I take it again in summary, your AUC score is just, your AUC graph or curve is just a curve that you use to show the coverage of your predictions. Your prediction should be between 0 and 1, like probability. So I want to see if when I finish plotting it, my curve will lie between that 0 and 1, which is the probability value, and every other thing in between. 0 and 1, look at it, it makes it. And the highest one I'm having is at 1, which is 100%. And that is it. So, and my AUC score, therefore, is my 100, which is the highest prediction I can have. So that means for every one that I'm predicting, my model is making the right prediction. And even if it's predicting 0, it's making right prediction based on the probabilities. But probability is high. Probability is 100%. So the prediction is accurate. That's the meaning. Because here, the highest probability you have, even if it's starting from 0, the highest probability here is around 100%. So therefore, for any prediction this graph make, this model make, is 100%, because the area under the curve is everything. It covers everything. That's what we are saying. Is it clear? Is it clear? Is it clear? Okay. Finally, finally, you have gone to bed. No, don't.
We did not go anywhere.
Okay. There's nothing to worry about. So when we get to our AUC is like optional. But if you do more work, the more you use it, you understand it. You don't need to, you can even put it somewhere, because you are going to be using it every time. This code I wrote is just going to plot the graph. This is the only thing you need to compute. Compute the model probabilities, the probability of the predictions, then put this thing together. Once you put this thing together, the probability inside, the next thing is come and write these plots. And you will see it. Once it displays, whatever you have here is the probabilities of making prediction. This one is just telling you that anytime the model make prediction, it's 100%. The probability of correct prediction is 100, which is good, which is what we are interested in. And we have been able to see this one right from when we did our F1, we call precision and accuracy, but we just want to see, does it cover the entire area in the curve? Yes, 100%. Is it okay? Wow. Is it okay?
Yes.
Don't worry.
Yeah.
Yeah, don't worry. There's nothing to worry. So we use it more. We use it more. Okay. So, but up to F1, you understand. The curve is not
Yes.
all this thing I've written, that's why you see it anywhere. So just master it. The interpretation is what matter. AUC is 100%. My area under my curve. If you do little differentiation calculus, this thing will not be difficult. Area under the curve, that is like the representation of the entire result is 100. That means the graph is well posed. It covers what you need to cover without not leaving anything out, basically. So these are the things you need in interpreting or be sure that your classification model is behaving very well. But if you want to get this one confused, once you get to F1, okay, you can now make summary. It's okay. We call is 100, precision is 100, my F1 is 100, accuracy is also 100, my confusion matrix is also fine. So therefore, this model is good, and you close your case, no problem. Okay? Any question?
Yes.
Any
No.
All right. Eziaku, any question?
We'll just read up on those other parts.
Eziaku, any question? All right. Lesson, any question?
No question. No. I'm already tired.
I know that's what you will say. Now we will ask you tomorrow. We will say that